There's Cadet Williams at the left. Remember the fellow we went through ground school and the trainer with? They've been cramming plenty into his head. He's been way up at the top all along. I wonder if he can get all that theory out of his head and into the bomb sight. What's wrong? Fine thing to be right on the nose and have that one come out of the rack. You had better get the habit of inspecting those now. Nobody's going to do it for you later. Master switch on. Right. Where's the checklist they gave you for the pre-flight inspection? Didn't you bring it with you? You know it by heart? That's fine. Bomb circuit switch on, right. Now what? Stabilizer gyro switch on. Telescope search knob moves the sighting angle index, so that's okay. Telescope motor clutch in. Displacement knob okay. And rate knob's moving the rate index. Don't leave it at 0, leave it at 0.5. Turn sight for maximum drift. Trail arm moves freely. Telescope tilting all right? Then your cross-trail mechanism's okay. Oh, so you learned it by heart. Well, you made it that time. Check sight stem locking pin and stabilizer connecting rod. And now? Servo motor switch on, right. Vertical gyros caged, so you turn on the bomb sight switch. Telescope crosshair illumination switch turned off. Check the secondary clutch to see it's disengaged. So now, with a little help from your partner, you can check the PDI. PDI okay. Now, check the directional clutch. Hey, you don't have to wrestle that sight to see if it's stabilized. Just listen to the servo motor growl. The turn knob moves the sight. And the brush. And the drift knob does not move the sight and does move the brush. That maintenance shop did all right for this sight. The turn knob allows a full 30 degrees freedom of movement each way. Rate motor running, like it was stirring up a chocolate milk. And your gear shift lever, according to that tachometer adapter, is, oddly enough, shifting the gears. You're in low. Try the other range. Home stretch now. What's next? Oh, yes, check to see if the trail arm positions the roller correctly. Set maximum disc speed. Your trail arm at 0. And your rate index at minus .05. Telescope index near center. Telescope clutch engaged. So the optics move backward. That's because the roller is below the center of the disc. Now, set in 50 mils of trail. And the optics don't move at all because the roller is smack in the center of the disc. That's okay. Only don't leave it that way or the roller will wear a hole in the center of the disc. Trail arm back to 0 and your rate index to .5 again. Then move the sighting angle pointer to the bottom of the indicator window. And now what about roller slippage? Set the correct disc speed for any corresponding time of fall by using your tachometer. The trail is at 0, so we start the stopwatch and telescope motor at the same instant with the indices matching. It takes actual time of fall for the telescope to cover whole range. So if our telescope index reaches 0 as our stopwatch reaches actual time of fall, then the roller isn't slipping. Leave stabilizer running so it'll be all warmed up. Hey, wait a minute. Are you sure you checked everything? All right, you're the one that has to sign the report. Sure you didn't forget anything? Okay, then. Anyway, if you did, it's too late now. Well, gentlemen, you've seen the pre-flight list. Did he forget anything?